My name is Thomas Francis. I'm an electrical engineer in my senior year here at Florida Tech. Basically, our project is to design a traction inverter, which supplies energy from batteries on board an electric vehicle and supplies it to the motor so that the electric vehicle can spin its wheels. And specifically, the motor that we have here is a Ford Mach Eluminator motor, and that's what we're going to be using to spin up in our project. It's actually the motor that they put into their newest electric vehicle Ford Mustang. A lot of people think, just have a motor, you plug in positive side, negative side, and it spins. This one, they work a lot differently. So this actually is called an AC motor. So it takes a sine wave as a signal essentially, and it has 3 phases of a sine wave. So there's different positions in this stator and resolver within this motor that allows when the 3 phases come into it, it makes sure it spins properly. So the traction inverter has to separate our power into 3 separate signals in order to turn this motor, instead of a simple, what's called a DC motor, where you can just attach it to a battery, positive side and negative side, and then that will start spinning. So this one's a lot different. It takes a lot more work in order to get it working. We're doing the testing phase of various components that go into that traction inverter. The MOSFETs we have been testing are cheaper, they're not as good, but if we can push those to the limits, that means we can test our good ones and test them safely. And we'll know that the good ones will be safe because these cheaper ones could handle it. So once we finish this round of testing, then we'll just double check everything with our higher quality components. Being the first sort of year that's worked on this, we're really just trying to get this motor to spin and spin efficiently. Now, we were donated this motor by one of the research professors here at Florida Tech. And what we're trying to do is, once we get it to spin efficiently, we're going to send this over to one of the research facilities here, and they're actually going to attach a flywheel to it, have some 3D sensors attached onto that, and then spin it up as fast as they can and just break it hard and do some analysis to see what happens. We get an opportunity to finally put all of the years of education that we've had to work on and everything like that, finally put it into a project that we can be proud of as part of a big team.